Welcome to the series of an overview on precast construction technology, a Lego construction. So in this video, we are going to focus on the construction, or we can say the basically precast boundary wall. We'll see the concept, we'll see different types of boundary wall, and we will also discuss how these precast boundary walls are erected on site. So first, let us understand the process, how it works. So basically, if we talk about the process of the precast elements, basically it starts with the concept and planning, where the deep or micro level of planning is required, in which the term concept means where the structural elements are divided into the number of elements for ease of for the ease of production, transportation and erection. So at the first stage, which is known as concept and planning, so basically the micro plannings are being done to analyze the precast elements into the number of varieties. Then after it comes into the design and production. So whatever the planning has been done, based on the planning and bifurcation of the elements, the design will be carried out, where all the structural points has been will be taken into the consideration. After that, after the final design, the production for the precast element will be done. After the production, it comes to the logistics. After the production, the elements are stored into the stockyard, or in some case, it is directly loaded into the trailers for the erection after achieving its required strength. So after the logistics, when the transport will reach to the site, it will be if the storage is available at the site, then the all the loaded or logistic items will be stacked on the site, and then it will be erected. Or else in another case, directly it can be directly lifted from the transporting trailer, and it will be directly erected on the position. And the last but not the least, it is the handover, in which all the process, which all the final finishings and all the comments and everything will be cleared, and finally it will be handed over to the client. So this is the huge, very wide view of the process, in which we have bifurcated into four different types, starting from concept and planning, design and production, then logistics, erection and handover. So in our previous videos for this series of an overview on precast construction technology, a Lego construction, we have already covered the precast elements such as hollow core slabs. We have also seen precast beams and precast columns. We have also covered precast staircase and landing, and we have also covered many other precast elements in this series. And in this video, we are going to focus on the mainly on the precast boundary wall, and we have also covered the stressing of how the hollow core slabs are stressed using the stressing machine. That video has also been made in this series, as well as we have also made we have also focused on how the stress for the hollow core slab, or we can say the stress it is required to pull this strand, has been considered in this series as well. So let us move ahead, and let us start with the precast boundary wall. Basically, precast boundary walls are wet mix. As you know that the hollow core slabs are dry mix concrete, whereas all the other precast items are wet mix concrete. Basically, wet mix concrete means the concrete which is basically a slumpable concrete, which has some slump in that one. So we can get a collapse slump, So basically it is known as the wet concrete, whereas in the hollow core slab we generally use a dry mix concrete, or we can say approximate zero slump concrete, where the element are produced using the machines. So in that case we need zero slump concrete, or we can say control mix. So basically in the boundary wall we will particularly we use wet mix. If we talk about the production of the precast element, or we can say the production of the precast boundary wall, basically in the boundary wall there is either a columns on the two sides and a sliding panel, or either it can be two columns and hollow core slab, or it can be a single panel. Okay, so in this video we will not cover the production procedure. However, the production procedure for the wall panel has been considered in this video, where we have covered the production in deep, and also the precast column, where we have considered, or we can say we have already discussed about the production of the column. So the concept ultimately remains the same, where it includes the mold, preparation of mold and fabrication, then the placement of the rio, or we can say the placement of the reinforcement cage, and then casting of the elements and demolding, and the third is the erection. So basically the production of the precast boundary wall is almost similar to the the production of the wall panel, or we can say the production of the column. So if you want to see the production procedure for that one, so you can please see these videos on precast wall panel and precast column. So let us just move ahead. So let us first understand the what are the different components of the boundary wall. So let us first understand the breakdown. Here you can see I have made the breakdown of the precast boundary wall. So basically let me start with the first. So here you can see this is the precast column, that is excluding foundation. There are also different kind of columns, that is column with the foundation as well. Here you can see this is the precast panel that will be slided between the columns. You can say this is the column 1, this is the column 2, and here you can see there is a groove in the column, and the panel, this is wall panel, and this wall panel will be slided from the top in these grooves. Here you can see these are the grooves on the column, and it will be slided. So we have the component first column, then we have wall panel, then you can see here we have the coping, and we have wall coping as well. So there are two different types of coping, wall coping and column coping. Above that, in some case, some of the client has a requirement for the barged wire. So here you can see they have considered the barged wire, and we have the Y-angle. So this is the basic concept of the precast boundary wall. Here you can see the level difference is 0. What do you mean by the level difference? Let's say in this case this is inside and this is outside. Okay, so the inside level and the outside level, in this case it is similar. So we can say there is no level difference, or we can say zero level difference. If let's say the inside level is here and the outside level is this, so in this case this is my level difference. So in that case the boundary wall may act in different case. So in that case we have to design a boundary wall in terms of retaining wall, because here we have a two difference level, where inside is lower side and external side is higher side. So here we need to consider while designing the boundary wall, we need to consider it as a retaining wall, because we have a soil on the other hand which has to be retained by the boundary wall. We will also discuss in deep for this concept in our previous slide as well. So let us first understand what are the types of foundations that are done in the precast boundary wall. So basically there are two different types of foundations that are carried out. So first let us, here you can see this is the pile foundation. Pile foundation means the pile has been done in the ground, and the pile, here you can see this is the pile cap, and a column, precast column will be erected on the pile cap. How it will work? Let's say this is the pile cap. Here we have the pile. From the pile cap, dowels will be projected out. Okay, and in the column, precast column, let us say we will see this section. So let us say this is my precast column. From the bottom side, we will have the dowel tubes on the bottom side, in which these bars will be connected. These reinforcement dowel bars will be connected into this dowel tube. So this how it will be connected with the pile cap, and then the grouting will be done. So this is the basic concept for the pile foundation. Whereas if let us come to the open foundation, the open foundation means this kind of foundations can be two types. Okay, it can be eccentric footing, or it can be eccentric footing. This is eccentric footing, and it can be concentric footing. So concentric footing means the load will be distributed equally on the both side, where eccentric means the load will be on the at some distance. So here you can see in this picture we have the column and a eccentric footing. Okay, so basically this is the column with the footing concept, with the footing. Whereas in the first type we have seen that in the pile foundation there is a pile cap which is done in cast in situ at site, and then above that the precast column has been erected over the pile cap, and the dowel bars that are projected out from the pile cap will be connected with the precast column. So let us see the both types into the deep. As I told you in the type 2, which was open foundation, let us come on to the previous slide. So as I discussed, there are two different types of foundation in open foundation. One is eccentric footing and second is concentric footing. So similarly, if you come to open foundation, here you can see first type is concentric footing, where the footing will be divided into both of the sides, and second type is the eccentric footing, where the footing is only on the one hand side. So it will be footing will be like this. So this is the eccentric footing, where this kind of footing is known as concentric footing. So it depends. Now it may be a question that when we can use the concentric footing and when can we use the eccentric footing. So the scenario is, if the plot limit is, if the boundary wall has to be placed inside the plot limit, or we can say in line to the plot limit, in that case we cannot extend our foundation or any element that is extending outside to our boundary wall limit, or we can say boundary limit or construction limit. So in that case we have to consider our foundation inside our boundary line. So in this picture you can see this is our boundary line, and in this boundary line we have considered our foundation for this column. For this column we have considered foundation inside the boundary limit. So this kind of foundation is known as eccentric foundation, and it is used where the boundary wall has to be in line with the plot limit. Whereas coming on to the another type, let's say concentric footing. Concentric footing can be used in such a type where the one plot, or we can say, let's say for example we have one plot, and the plot owner is one, and the owner wants to split that plot into two area basically. So in that case, when a boundary wall has to be made in a common plot, in that case we can split the foundation in both sides. So there we don't have any limit for the boundary limits. So when it is an external wall, definitely we need to consider the plot limit, or we can say construction line or construction limit, where we cannot extend our elements, or we cannot construct anything above that limit. So in that case we are considering eccentric footing. So now let us understand the erection sequence for both types. So first we will go with the pile foundation. So the erection sequence for pile foundation. So in case of pile foundation, the thing is, the first thing will be the auger will be used to drill a hole into the ground, and then all the dug soil will be removed out using the auger, and then the reinforcement will be lowered into the pit, and then the concrete will be done. So this process is known as cast in situ process. Let me just bifurcate, or let me just make the difference between cast in situ and precast. The activities that are done in the activities that are done on site is known as cast in situ, and the elements that are ready made in the factory and then erected on site is known as precast elements. So here you can see this is the cast in situ procedure, where the auger drilling is done, and then the casting inside we can say the casting inside the pit has been done. So this is how the number of piles will be drilled into the ground based on the specific requirement, as well as the depth of the pile and the diameter of the pile depends on the soil bearing capacity as well as the load on the structure. So here you can see there are number of piles that has been drilled into the ground, and above that there will be a boundary wall that will be placed. So now let us move on to the second step for the erection sequence of precast boundary wall. So as I discussed that after drilling, let's say this was the drilling where the auger will be used to drill the pile foundation, and then the concreting will be done into the pile after placement of the reinforcement cage, and as well as in some case steel lining is also used to protect the excavated area from the soil surrounded with the pit, to avoid the the falling of the soil into the excavated area. So after the placement of the reinforcement into the excavated area, the concrete will be poured inside, and then the pile cap will be made on site, which is known as cast in situ part. After that, from the pile cap, the number of dowel bar will be projected out for the erection of the column, precast column. So above that, the precast column will be erected like this, as we discussed, and then the panel will be connecting like this. Similarly, there will be another column here which is connected with the pile cap, and there will be a dowel bar. So this is how it will work. Now next, as I discussed, after the placement of the after the casting of the pile cap, here you can see this is the pile cap. We have pile, this is pile, and this is pile cap. Okay, so now in the third step, we can see the preparation of the pile cap and erection of precast column. Here you can see this is the precast column PC. This is cast in situ pile cap, and this is pile. Okay, so here you can see this is the precast column has been erected using the crane. This is the mobile crane that is used to erect the precast column. In this picture also you can see there is a pile cap and we have the column, and that is connected with the threaded nut and bolt system. And at the last, after the erection of the columns, here you can see the number of columns has been erected. This is one column, this is two column, and between these two columns the wall panel will be slided from the top into the groove of the columns. So here you can see these are the panels, this and these are the columns. You can see that there are the grooves on this both side of the precast column, and the panels are slided down using the crane, and this is how the boundary wall has been constructed above the pile foundation, above the cast in situ pile foundation. So basically this part is in cast in situ, and the above structure, above the ground level, this structure is in precast, where the precast column is being placed and then the wall panels are slided down. Hope it is cleared. Now let us see the erection sequence for the open foundation. So in the previous slides we have seen the erection sequence for the pile foundation, and now we are moving on to the sequence for open foundation. Basically here in the open foundation, the PCC, basically PCC is required at the bottom. So cast in situ PCC has to be done. Why cast in situ? Means the PCC is done on site, so we will say it is cast in situ, whereas the column and its foundation is prepared, or we can say it is precasted in factory, and it is directly to be installed on site, so that will be precast element. So here you can see this base will be cast in situ PCC, okay, and then you can see this is the precast column base, or we can say this is precast column foundation, and then the column will be resting, precast column will be rested above this, okay. So this is the first, we can see the preparation of the PCC. Here in the here in this picture also you can see this is the cast in situ PCC, then in on site, and some of the dowels has been projected out to connect the column, okay. So here you can see clearly, we can see that column has been erected. Second step, after the placement of the precast footing, the column has been erected above the precast footing. It can either be a single unit known as column with footing, or either it can be a two type of it can be split into two types, precast foundation and precast column. But the general use in general practice, the feasible one is a combined one, in which it can be said at column with foundation as a single unit, okay. So this kind of element, it is a single element which is feasible for precast, where to avoid number of joints, because if number of joints will be more, the element erection time will be more, and joint is always a joint. So if we will make it as a single unit, then it will be faster in erection, and the speed of work will be more. So in the second step, we can see the placement of the precast column over the cast in situ PCC. So we have seen above the PCC, we have already placed our precast foundation, and above the precast foundation we are connecting precast column. Either it can be a single unit precast column with foundation. Coming on to the step number 3, erection of precast wall panel. Similarly, as we discussed in the pile foundation, after the erection of the column with footing, we will slide our precast panel with the, we will slide our panel between the columns and columns with the grooves. So basically the column will be like this. The columns will be provided with the grooves, in which the panel will be slided on both the sides from the top. So this will be the connection detail for the column with sliding panel concept. So here you can see the columns are there, 1 and 2, and the panel has been lowered from the top side between the grooves. Now let us understand how the precast boundary wall works in case of slopy area. So let us say we have the slopy area. So here you can see the ground profile is not in level, it is changing at each level. So in that case what we can do is that in that case we have to maintain the depth of the foundation. So the depth of the foundation remains the same. So this is the depth of the foundation. Okay, you can see all the depth of the foundation remains equal below the ground level, but the boundary wall level is changing. So this kind of this kind of boundary wall in counter site is known as the steps in the boundary wall. So this how it can be it can be erected in case of the slopy ground. Whereas in case of level ground, there will be no level difference, or we can say there will be no step will be seen in the level of the top level of the precast boundary wall, because here also you can see there is a slopy ground, but the ground has been filled into this equal level. So this is the filling that has to be done in future. So here you can see the top level of the precast boundary wall remains the same, whereas the foundation or depth of the foundation changes to with reference to the natural ground level. This was the natural ground level, so we have to consider foundation below natural ground level, and the total height will be increased, and the future, or we can say the ground fill or finished ground level will be equal throughout. So this is known as the level site. So in case of level site, the top level of the compound wall will be same, whereas in the counter side, or we can say where the level difference is I mean the ground profile is changing, in that case we have to consider a step in the foundation, the step in the foundation as well as step in the top level of the boundary wall. So this is the two different cases where the top level of the boundary walls can be change, or it can depend on. So now let us move to the types of boundary wall. So these are just some of the general cases that that can be considered. So first one is the compound wall with coping. So here you can see this is the coping, this is the coping, this is this general type, it is not the fixed one. This is the basic type of compound walls. So let us move on to the second one, that is known as compound wall with coping and grill. So basically it is a compound wall with the coping and grill on the above. Okay, so we have compound wall with grill. So we have the column, precast panel, precast column, and a steel grill above. Then we have compound wall customized surface. Because what do you mean by customized surface? Means the precast element can be gray color or it can be a colored concrete. If I say color concrete, what is color concrete? So basically color concrete is a pigmented concrete, in which the concrete will be mixed with the pigment, where the white cement will be used and a special kind of aggregates will be used to make a special kind of exposed surface or pre-finished surfaced boundary wall. So that are known as the customized surface. It can be sandblasted surface, it can be exposed aggregate, or it can be acid washed surface finish based on the client requirement. And last but not the least, we have compound wall with the customized design, or we can say honeycomb surface, for example. So what is customized design? Customized design means if some client want some of the architectural purpose or the architectural fashions on the outer side of the panel. So in this case, some of the rubber pattern will be used to form that particular design on the boundary wall. So these are known as the boundary wall customized design, or we can say patterned boundary wall. Okay, so these are the basically wide range of the boundary wall, starting from normal, then with grill, then we have the coping, we have the colored concrete, or we can say customized surface, and last but not the least, we have customized designed, or we can say designed external design surfaced boundary wall. Now let us move to the actual era where we are seeing the different types of boundary wall in the real world, or we can say in the reality. So here you can see the real picture, that is type 1, that I have bifurcated type 1, that is precast boundary wall with precast hollow core slab. So basically the concept remains the same. Here you can see we have the column with footing as a single unit on the both side. We have the column with footing as a single unit, and we have hollow core slab. You can see this is hollow core slab. In the section it is clearly seen. This is the hollow core slab that is slided between the grooves. So this is the type 1 which is used in general practice, or we can say in our day-to-day practice. These are the types which are particularly used in our day-to-day use. Okay, so the type 1 is precast boundary wall with precast hollow core slab, or we can say column with footing plus hollow core slab. So this is column with footing, and hollow core slabs that are slided down between the grooves of the column. Moving on to the type 2, we have precast boundary wall with solid panel. The concept remains the same. It is same as precast hollow core slab. Just the difference is that here we are using solid wall panel instead of hollow core slab. So here you can see this is the solid wall panel. Okay, so we have the column with foundation or column with footing and a solid wall panel that is slided between the column. So this is column with solid wall panel. Okay, now type 3. What is type 3? We have precast boundary wall with foundation, or we can say panel with footing. Simple, which means there is a panel and it has some individual footing. So this is the panel, this is our boundary wall, and it has an individual footing. Here you can say this is the panel and we have the footing. So basically this is known as panel with footing. Coming on to the type 4, we have precast retaining wall, where we have retaining wall and we have the foundation. So this is retaining wall with footing. So as we discussed in our previous slides, that retaining wall can be considered when the level difference is more. The inside level and the outside level is not at the same level. In that case, we have to consider basically a retaining wall. Or the thumb rule is that if the level difference is more than 1 meter, or we can say it is equal to 1 meter or more than 1 meter, we have to consider, or we have to design a boundary wall as a retaining wall. So here you can see this is the internal level difference, and we have this is the external level difference. So you can see the level difference is too much high, or maybe more than 1 meter. Okay, so in that case the this retention has to be resist by some retaining structure. So in that case we have considered this as a retaining wall as a single unit, and then we have the precast boundary wall, and that will be connected between, there will be a connection between retaining wall and precast panel that will be stitched on sides. So this is precast retaining wall and this is precast boundary wall, and even you can see the boundary wall is with the steel grill opening. As we seen in our previous slide, we have steel grill opening retaining wall. Let me show you. So here you can see this is a steel grill opening has been provided in the boundary wall. The same concept comes into the picture, where here you can see there is a steel grill provided for the aesthetic purpose. Coming on to the type 4, that is known as cast in situ wall with precast column and hollow core slab or solid wall panel. So basically it says that this is basically cast in situ retaining wall. This is the case where, let's say, we have the basement, or we can say -1 level is there, okay, where the retaining wall has been done in cast in situ, and then above that, above the ground level, we have to place the boundary wall. So in that case, the cast in situ retaining wall are already been constructed at site. Now the dowel bar projecting out from the retaining wall will be there, and then we have to just erect our column, precast column, with the cast in situ retaining wall, and then we have to slide the precast panels or hollow core slab between the grooves. So basically this is the cast in situ retaining wall plus column plus hollow core slab or solid wall panel. Last but not the least, we have cast in situ retaining wall with precast boundary wall. So this concept is similar to type 4, where we have considered retaining wall as a part of precast, where in the type 6, here we have considered retaining wall as a part of cast in situ. Why? The reason is that it may happen that the retention between, or we can say the retention will be more than 4 meter, or depending on the site situation where we cannot, or we can say it is not feasible to make a retaining structure in precast. In that case, we have to consider the retaining structure as in cast in situ part that will be done on site, and then the above structure, or we can say the structure above the retaining wall, that has to be considered in precast. So here you can see the hatched area. This is the cast in situ retaining wall that will be casted on site, and then this precast wall has been loaded, or we can say the wall has been rested on the retaining wall, and then the stitch connection has been done. So this is one of the situation where cast in situ retaining wall with precast boundary wall panel can be used. So this was all about the precast construction technology for the precast boundary wall. We have also various videos on hollow core slab, we have wall panel, we have staircase and landing, we have column, we have pre-stressed beam, we have load test on hollow core slabs, and many more videos on the civil engineering line. So you can please visit the other videos, and you can just check other videos for the series of an overview on precast construction technology. It was grateful. Thanks for watching, and stay connected. Thank you so much. Bye bye.